Now let's talk about the last application of probability in our course, An Intuitive Introduction to Probability. It's a sad story of a woman in England by the name of Sally Clark. The story starts out okay. Sally Clark was born in England in 1964. She married a gentleman by the name of Steve Clark in 1990. They moved to a house near Manchester in 1994. Both of them worked together at a law firm in Manchester. Their first son, Christopher, was born in September 1996. So far, so good. A story like you may have heard many times, a happy couple with a baby. And then tragedy struck. The baby falls unconscious in December 1996, so just a couple months old, and dies. Sally is home alone with the boy. Now, the baby shows some signs of trauma, but the doctor thinks maybe while trying to revitalize the baby or bring it back from lack of consciousness, this may have happened. And then the death is believed to be what in the United States is called SIDS, the Sudden Infant Death Syndrome. In British English, people talk about cot death. This is this occurrence of babies somehow falling asleep and then dying or lacks of oxygen in the first year of their life. There are various theories why this could be. Even though the medical profession has made a lot of progress in trying to analyze the reasons for SIDS, it's still sometimes a bit mysterious. Nowadays, parents get the advice that babies should sleep on their back, not on their tummy, so that this reduces the probability. They changed that a couple of years ago. Let's hope that they are right this time. Now, about a year later, after Christopher dies, the second son, Harry, is born in November of 1997, and the next tragedy happens. The baby is found dead, Harry, in January of 1998. Again, the mom, Sally, is the last person to see the baby alive. Now, the baby, looks suspicious. Two babies suddenly dead, and this baby shows some brain damage, and people are maybe from shaking the baby. Maybe deliberately shaking the baby or something. Now, because of this suspicion, Sally and her husband Steve are arrested on double murder charges. So now, some people think this can't happen. Two babies die. The parents were just sick of the baby. Babies cry too much. They killed the babies. In particular, they go back to the report on the first baby and change ex post the diagnosis from natural causes, cot death, SIDS, to smothering. Maybe playing too hard, maybe deliberately, maybe pushing the baby too hard, or whatnot. Eventually, though, the charges against the husband are dropped. The mom is the main focus of the accusation now, because in both cases she was the last person who saw the baby alive, and now she's accused of murdering both babies. She flat out denies the charges. The husband continues to stand by his wife and to support the wife and says, no, my wife wouldn't do these things. In addition, they have a third baby born in 1999 during the proceedings. In court, there's a key argument by an expert witness who says the following. The two SIDS cases in the Clark family have a probability of 1 in 73 million. It's so unlikely that this happened, it must be two murders. So the expert witness very strongly makes a point that he believes the mom killed both babies. The jury is clearly impressed by the expert witness and votes 10-2 of guilt, and as a result, Sally receives a mandatory sentence of life imprisonment. So, let's have a good probabilistic look at the statements of the expert witness. How did he get this 1 in 73 million? he starts out, he says, I looked at the data, I looked at families like the Clarks, and he started out with a probability of a single SIDS case of being 1 in 8,573. Now that's by itself is nowadays considered a dubious estimate. There was in the past a lot of controversy about this. It's quite unclear what that correct number should be based on relative frequency data. For the sake of this discussion, let's keep the number as is. Personally, from what I read, this number is way too low. However, again, as I said, for the discussion of what comes next, let's believe this number. Then this expert witness said, oh, we had 2 SIDS in a row. So, let's assume independence. At this point, warning bells should go on in your head. But that's what this moron said. Let's assume independence. 1 in 8,573 times 1 in 8,573 is about 1 in 73 million. So, the probability of 2 SIDS in a row is 1 in 73 million. That's how he came up with the number that he gave in court. Then he said, oh, jury, you don't understand what that probability means. Let me illustrate it for you. We have about 700,000 births in the United Kingdom in a year. We should see this once in 100 years. That this happens accidentally. And then, and this really hit home in this country of sports fanatics, the UK, he said the probability of a double SIDS is as likely as you bet money on the 80-1 outsider at the biggest horse race that the country knows in a year, and you win 4 years in a row. And so these statements that the expert witness made to the jury apparently visibly impressed the jury and led ultimately to the 10-2 verdict or vote that then led to the verdict of guilt. Now, there are at least 2 terrible mistakes, and not even talking about the 8,573. The first terrible mistake was independence. Do we really believe that if this SIDS, about which we don't know much, happens to a poor family, that then afterwards that reveals no information whatsoever? So here's essentially the assumption of what the expert witness says. He said the probability of a SIDS on the first baby and SIDS on the second baby is just the product of SIDS on the first baby times SIDS on the second baby, and moreover, SIDS on the second baby is as likely as SIDS on the first baby. So those probabilities are the same. Do we really believe that's a reasonable assumption when it's a condition about which we don't know much, where there may be God knows what genetic factors that we haven't really explored yet, about a really mysterious nature? Shouldn't we look at, instead of conditional probabilities in empirical data, to estimate these numbers? No, he didn't do that. Later on, people did this, and they realized the conditional probability of a second SIDS case in a family after having a first one actually increases a lot over the unconditional probability. I found estimates, actually here I wrote as large as 1 in 200. Recently I found numbers as large as 1 in 100 or even 1 in 60. That means if a family has a SIDS case and then this couple has a second baby, for whatever reason, nowadays doctors think there may be genetic reasons, the probability is drastically increased, and these people have to be extremely careful. There is something like a genetic predisposition. So that means that this number of 1 in 73 million is way too small. The second probability is not 1 in 8,573. It's something much larger, and as a result the product gets much larger. But things get worse. Here's our second terrible mistake. The prosecutor's fallacy strikes once again. Here's a brief summary of the prosecutor's family as a reminder for you from our previous lecture. And these are exactly the cases we have. The damning evidence versus the innocence of Sally Clark. The expert witness said the following. Given that Sally is innocent, there's a 1 in 73 million chance of 2 Sid's deaths in a row. But then came the prosecutor's fallacy. He said that means the probability of her being innocent is 1 in 73 million. No, in particular, of course, this being in the UK, there's a huge yellow press. Yeah, people then communicated there's a 1 in 73 million. This poor woman, Sally Clark, is innocent. Wrong. This all is a prosecutor's fallacy. We need the flipping formula. We need base rule to think about. What's really the probability of innocence? And this now then asks us, if we want to think about the various inputs that we need into base rule, what are the alternatives? If the woman is innocent, what are the alternatives? Sids. If she's guilty, it's murder. What's the data on guilt, on double murder of 2 kids? That's also not so likely. Actually, people later looked at data. And Sids is estimated to be 4 to 9 times more likely than double murder. So the calculation of base rule was never done in the trial, but people should have looked at probability of innocence, probability of guilt, and looked at murder versus Sids. All this was never done, so the prosecutor's fallacy was never resolved. So to summarize, at least 2, some people argue 3 and more terrible mistakes were done. For the sake of our discussion here, 2 terrible mistakes. Multiplying independent probabilities and the prosecutor's fallacy. Sally Clark or her husband appealed the case, the verdict the first time in October 2000. The appeal was rejected. A second appeal in January of 2003 was successful and she was let go. There were at least 2 more women who on Sid's charges had been sent to prison. They were overturned and were let go. There was an ongoing trial where then the woman who also had lost actually 3 babies was allowed to go free. So this has huge implications in how Sid's cases were handled in the United Kingdom. Sadly, Sally really should have left prison much earlier. As early as October of 2001, the Royal Statistical Society of the United Kingdom made the statement that the 1 in 73 million figure has no statistical bias, and in their statement, in a press release, they very clearly pointed to the mistakes of the expert witness. You cannot assume independence, and clearly the jury had a case of the prosecutor's fallacy. So clearly there were these 2 terrible mistakes. Now Sally goes free in 2003, but still the story ends sadly. Sally never recovered from the traumatic experience of losing 2 kids. She became dependent on alcohol and died of alcohol intoxication in 2007 at the age of 42. She's at the time survived by her husband and the 3rd son. The 3rd son lived happily ever after. No Sids, no murder, nothing. So after all this, nowadays people believe Sally Clark was indeed innocent, and this was a terrible miscarriage of the court. There's a huge amount of information on this. The Sally Clark family has a website where you find much more information, in particular also on the probabilistic aspects. One of her lawyers wrote a book on the case, John Batt. And finally, for those of you who are interested in law, there's a lovely book called Math on Trial that looks at other mistakes related to math and probability and statistics in court, And so for those of you who love the law and perhaps are interested in studying this field, take a look at this book. To summarize, beware of prosecutor's fallacy. Do not multiply dependent probability very hard and focus on dependence versus independence. Because if you screw this up, tragedies may happen. This sums up our module on applications. I hope you had as much fun as I did on looking at the playful applications at the very beginning, the birthday problem and the Monty Hall problem. Then looking at the business applications, how in structured finance the problem of dependence versus independence led to many serious troubles. And then finally the terrible implications of prosecutors' fallacies has in court. Now in the next module we will move on to what's called discrete random variables, and we're going to look at metrics such as expected values, variances, standard deviations and other numbers. So please come back for the next module. Thank you.